Hey guys, my name is Barkha Herman. I work for Microsoft as a cloud architect. And I'd love to hear from some of you guys what roles is represented here. How many of you are devs? Developers. Architects? Okay. How about ops? People from, okay. And how about just people managers? A couple of people, one token. All right, just out of curiosity to see who would walk into a session on the rise of ledgers. So it's interesting. So here's the agenda for today's talk. Who am I? Where have I been? So I always like to put some context to why you should listen to me. And then, my focus these days has been on data. You've heard data. Data scientist is like a new thing. Not that new, but it didn't exist 10 years ago. And so data collection is maturing, to say the least. And so in reference to data collection, we're going to talk about a couple of patterns. One is CQRSES, and the other one is blockchain. And both of those represent a new way of looking at data. So that's me. I'm a mom, wife, technologist. I like to climb rocks, and I like to cook. 30 years in Florida, living in Florida, originally from India. That's my email if you need to contact me. We're actually working on some projects, open source projects based on the two patterns that I'm going to talk about. So I'm open to collaboration, so feel free to contact me. And a couple of quotes, just to make things interesting. I won't really dwell on this, but these are some of the places I've been. And so back, way back. So the earliest evidence of accounting is from Mesopotamia. That's from 5000 BC. And so that's 7,000 years ago. Has anybody heard of the Linde Effect? Does anybody know what that is? So the Linde Effect is this observation that if you want to look at a technology or an idea, a technology or an idea, if you want to guess how long it's going to survive, how perishable it is, you look at how long it's been around. So the longer it's been around, the longer it's going to stay. So, fads come and go. Anyone remember things like Palm Pilots? Fads, yeah. But, accounting is an idea, a methodology that's been around a little bit. It's going to stick around. So that's the Linde Effect, and the idea is that, accounting is here to stay, and we're, as computer scientists and data scientists, we're moving towards accounting. So this is the 90s. Again, anybody remember the 90s? So we had these, fancy names, 2-tier architecture, 3-tier architecture, distributed systems. This was what was going on in the 90s. But what was happening with data? Anybody? Yeah, basically, the database was like, 2-tier means I have a database, and then everything else lives in a space. And the data is volatile, right? And then 3-tier is just, I put a middleware. So all architecture was focused on how you deploy code and where you deployed code, but there was really not a lot of stuff going on with the data. People weren't that concerned about data. We didn't have that much data. We didn't have, phones that tracked everything we do every second. And so data wasn't really a concern. Even in the distributed systems, the data wasn't. So what is the biggest database in the world? Does anybody want to, the most distributed database in the world? Does anybody want to Guess? Do you want to check? It's not necessarily, well, my answer is DNS, right? It's the most replicated database in the world. Yeah, not technically a database from the point of view of, oh yeah, you know, IBM invented SQL and then Oracle came along and that way. But so that's the beginning of the distributed system, by the way. So neural nets were introduced back in 1968. I've been reading The Dream Machine. Anybody read that book? Amazing book, by the way. Everybody in computer science should read it. So, you know, the worldview was hardware-centric and software-centric, not really data-centric. And then data started becoming ubiquitous in later life. So this is how we would deal with data. We would have an insert, then we would have an update, and then we have another update, another update. And what are we doing here? We're losing all the history of data. We have no idea how we got to the present state. So we had all massive data, and you know, yes, we had backups, and those were all afterthoughts, right? And you could restore to a point, and yes, you know, you have database technologies evolved to the point where you can do restore from up to the minute. Especially now with cloud computing, it's becoming a little more easier to do that kind of stuff. But still, you don't have a complete history of what happened to data, right? Code, yes, because we started using source controls of different types. So we actually keep track of what we're doing to code, as well as hardware with updates and patches and everything. Well, what happens to data? Data is the most volatile part of a programming paradigm for a very, very, very long time. Questions? So then, I think Oracle was the first one to came with history tables, and we started doing this thing. That, oh, for every table, we're going to have a history table now. So yes, you have a user, and you have a history table. So every time there's an insert, there's a snapshot of it in the user history, but then every time you do an update, there's also a snapshot of it. And so typically what happens is that your user data is very small, but your user history is humongous. And then, you know, if there's any schema changes or anything, now you have maintenance hell.
How many different snapshots of history do they typically have?
Every updates. So it's like, you know, it's an afterthought of data preservation, right? Data history. So you would have product history, order history, blah, blah, blah. So this model is great, but who can access it? Now you have to write like a whole UI to maintain the history tables. You have to have pipelines to deploy the history tables. Any schema change. You have triggers. So now your triggers are actually slowing down the actual, you know, your OLTP, online transaction processing. So anybody dealt with history table in this room? Yeah. So that was our way of dealing with an oversight of data volatility. We have consumer data, customer data, enterprise data, and then we keep overriding it. And now we have to patch it by creating these history tables. So what about performance, right? And what about maintainability? So, so there are two trends that actually shifted the way we deal with data completely. One of them is command query segregation. Have you guys, anybody heard of it? Yeah. So the whole idea is that what you want to do is you want to separate your reads and writes. So all your writes go into one database, and all your reads go to another database. And it's more for performance than anything else. So you can have your writes go to, let's say, active database, and you can have history tables there. But the read table doesn't have to have any history table. So now suddenly your performance is so much improved because the only place you're maintaining copies of the data is in the write. And since the write is fine, writes tend to be slower than reads. Most of the performance is read heavy. So you run your reads and bulk reads on this side. And so now you have performances again better. You can also, it's better for security because you can give read access to a lot of people. You give write access separately. So you can actually segregate your reads and writes. So this is where, we're moving into the 2000s now. We have some patterns. We're using MVC, MVVM patterns to maintain this. And then, we have this segregation between application, write model, and read models. So we're even coding differently from a data point of view. So the key concepts here is segregation of reads and writes and actions as well as models. And then the next pattern, and this is a parallel pattern that emerged, which is called event sourcing. So anyone know what event sourcing is? Yeah. So this is pretty ubiquitous these days. So basically the idea is that the application raises an event, and then the event is handled, and then something is done based on that event, right? So the advantage of event handling is you can raise an event, and there can be n number of consumers. So if you have a piece of data, let's say an order is placed, and it needs to alter the cart, the inventory, it needs to send a packaging label or whatever, 10 departments that need to be updated. They can all subscribe to the event, and then they can respond to that. So the genius of Greg Young, who's actually spoken at this event before, is he's the one. So this is key concepts here is events, not endpoints. And more than one process can respond to an event. And there's a built-in audit log because every event is actually a log of the system as to what happened. So an event is the log. So now when you're consuming from an event, you can write it in different ways, but you still have the event logged somewhere, and the event is actually the what happened at any given point. So you have a built-in audit trace. So the advantage also is that you have different entities having different point of views. If I'm the order and the labeling department, all I care about is where the order is going to. I don't really care what's in the order or how much money is in the order. And all I extract from the event is the shipping label information. So I don't have to know, the rest of the event. So you have different views. And so the genius of Greg Young is that he's the one who presented the CQRSES pattern, which actually combines the read-write separation as well as the event sourcing. So again, anyone familiar with this pattern, CQRSES? Yeah. So it's a simple pattern, but it separates the reads and writes. There's command query segregation as well as event sourcing. So not only do you have the log of everything that happened, and now you also have the read writes are separate. So you have the entire pattern that takes advantages of both read write segregation as well as event sourcing. And it's more maintainable.
What's the aggregate stage?
So the aggregate is a view of the entire system, one view of the entire system, right? So
just analytics that you want to do, you're going to feed back the command handler back in the right database into the database?
Right. So here's the deal. So let's say that I get an order request, right? So the order request it generally looks like a cart, a shopping cart goes to the system. That's where the aggregate comes in, and it'll actually, so there should be multiple lines going from the right database to the aggregate, right? So the command handler will write the command to the system, and it'll actually create the multiple aggregates. So the aggregate could be the order itself, and then the other aggregates may be the label aggregate or whatever. So each aggregate compiles their own view of the system. And so the aggregates actually will raise the event, and then you have the read database writes. So there's two writes. One is the events. The other one is all the views.
So like a sort of, in practice, this would not be flat. You take this pattern, you repeat across, and basically your original data would be denormalized into different patterns, stored
Correct.
in different write databases, cascade to the bus,
Correct.
storing their own read database for consumption.
Correct. So, I mean, there's a possibility that you can have one aggregate that raises 100 events, which is really a bad pattern, or you can have 5 patterns that each raise 10 events each or whatever, something like that. And then the aggregates will actually raise the events to deal with all the other systems. So the event handlers for each system will handle. So there'll be an aggregate for maybe the order, maybe the label, maybe something else. And then it'll actually raise the event so that the other systems can talk to it. The maintainability comes in because if I want to change the way the labels are printed, I don't care what everybody else is doing. I don't know what the rest of the data looks like. All I know is my system and what the actual event looks like to handle it. And I can change it all day. Everything is compartmentalized. All the codes are independent, and you don't have to worry about it. So one of the advantage of this is, and so this is something that this is a project that we're working on right now, is that one of the things that you can do is you can play back the events from any time. So if you want to migrate data and you have an updated system, you just play back the data from the beginning. And now, if zip codes become more complicated, now you have new zip codes everywhere or whatever, you want to change some data, you just play back and you can rebuild your views based on playing back the event. But something like GDPR, what do you do when a employee comes and says, hey, I commented on your website, but I demand that you remove my data from your website now? The advantage, the future, is that you can unplay that. Because it's an event that's been played, but you can unplay it. And if you unplay it, think about the ramifications of all the data. So maybe a person created, a person comes to your website, created an account, and then made a comment on a blog post or something like that. You can actually unplay all the events by this person so that now their data is no longer in the system, because the views no longer exist, and then you can unplay the commands as well. So if you, and I don't know if you guys are implementing GDPR, but it's coming to the US. So things like that. If I actually am required by law to undo a piece of data for a customer, now you have the ability to actually implement it without really changing anything in the system, but it gives you a lot of control over what's going on with your data. Does that make sense? Questions? The other thing is you can export all your data. Let's say that you have this massive website or blog that you've been running, and I know this is a lame example, but you've been running it on WordPress for 10 years, and now you want to move it. You don't want to lose all your data. If it was using event sourcing and it has all the events, you now have all the events. You can run it against another platform that can replay it, and maybe the new system, instead of writing it to MySQL, writes it to Cosmos DB or MongoDB or something like that. And it's a completely different data set. You still have your entire event source, and you just replay it. You download your event data. You can actually download it. It's kind of like, almost like downloading your medical records or whatever, something like that. It's your data. You created it. Now you can easily replay it in any platform of your choice. And now you have historic data on the day, what edits you made, everything. Does that make sense? And the new system doesn't have to be in the same platform. It doesn't have to write to the same database. It doesn't have to be in the same coding language. It could be anything. But you have.
Can that be any granularity? So, for instance, only a certain custom for a certain class of products. See what I'm saying?
Yeah. So and it depends a little bit on event sourcing. You can go to each event that was raised, or one of the other things is that every event raised by X, or it could just be all of it, right? So the granularity can be anything. You may not track everything in an event that's relevant, but you can always filter the event and find the ones that matter to you. So if you want to say, hey, I want to roll back everything that happened on Wednesday last week, then there's no key, but there's a timestamp on it, so you can do that. Or you can say, hey, I want to roll back every event that Barkha raised, right, as a logged in user. So does that make sense?
Yeah. So any event where I sold a certain medication that was recalled by the FDA.
There you go. Yeah. I like the way you think, though.
How does it handle orphan records?
Sorry?
How does it handle orphan records? Say you have to unplay a blog post, but there are 5,000 responses to the blog post.
Yeah, so we would have to unplay the responses as well. So because the view is volatile, the view is buildable, right? So what you would have to do is you would have to identify all the events that you want to unplay and then find any dependence on it. So you can leave them, they won't show up because it's a blog post and the comments are related to the blog. It won't show up anywhere. You would still have a response. But you probably want to get rid of it because if it's a GDPR type of thing and I'm saying, hey, I have a really unpopular opinion that maybe we should never go to the moon again, or Mars, which is unpopular. And somebody says, what do you mean you don't want to go to the moon? Well, the data privacy requires that this person is quoting you or this person is talking about what you've posted, so that also is covered in the GDPR laws. So you're going to have to unplay that anyway. So yeah, you will have the visibility. I'm not saying it's easy, but it's doable. And we actually have a working prototype of the website design that we're talking about. So
Practically, what type of data repository would you store these logs in? Because as this thing gets huge, and it will over time, it just seems like replaying and accessing and being able to pick out certain parts of the logs is very challenging.
Yeah. And so if you've actually played with any of the libraries that deal with CQRS implementation, CQRS-ES implementations, you have this thing called snapshots. So there's snapshotting. So what you do is you can, if you have a really chatty app, so if you think about it, like let's say that I have 10,000 customers on my CRM, right? Let's say I'm Amazon and I get things delivered to me all the time, right? But seriously, if I look at my data on Amazon, I don't know what they track, but if I look at my order data on Amazon, it really is not that much.
Well, a different example with Amazon, the Alexa controversy they had where they were deleting recordings. You may only have had 100 conversations with Alexa, but if that's in the database of all conversations Alexa everyone's had in the country or across the world, picking out just your conversations to remove them and delete them
Right.
seems like a very big challenge.
Yeah, and that's where the snapshot helps. So what you do is, so you have the massive data store for the event source, and then you have snapshots. So the snapshots are roll up of everything, and up till this point. And so you still have the events from the past if you need to use it, but the snapshot gives you the ability to have a rollback point. So then you have your 500 views, because I can go to Amazon and look at, hey, when did I start using Alexa first? And I have that in one of my read data sources. Say, oh, I really started using Alexa in 2018. So I know that I need to go back to the snapshot of 2018, January, whatever, in order to do that, as opposed to all time, forever.
Yeah, I think to the conceptual standpoint, what we see around event sourcing CQRS is a lot of developers will then, on top of this add domain-driven design, depending on what event sourcing kind of library you use.
Right.
They have concepts like projections, which help simplify this re-aggregation of data. But, I haven't seen anything where this stands alone. As
Right.
a developer, there's typically a lot of other patterns on top of it to simplify for your developers and to simplify the re-aggregation. As
Right.
you described it as an aggregate.
Yeah.
The re-aggregation when you tamper with the history of the events. And so
Right.
I haven't seen it positioned quite this way yet. So
Yeah. Yeah, so this is just a new way of looking at it, because, with the patterns used the way they are, you have the opportunity to develop something that, that's replayable. And then also destroy, move your data, deplatform. So we talked about, the website example. If you have 10 years of blogs, God knows I do, I'd love to keep it and change platforms. I really can't right now. It's very ugly, the process. But if we started this way, we could actually replay all our events, just download events, replay it, and Bob's your uncle. So what's that got to do with the ledger, you ask? So a ledger is a double entry bookkeeping system. So the double entry here, the parallel here is that you have the event as the first entry, and then your projections are the other entries, right? So, there's double entry. Cash receipts, expenses are tracked separately. So those are your projections, really. Your labeling system, your read-only data is there. Alterations are additional line items. They're not overwrites. So in other words, when in a eventing system, you say, I wrote a blog post. Oh, I proofread it and fixed all the typos. I added some links to it. I added examples. So those are all additional things. They're never destructive to the original data. So that's similar to a ledger. So what we're moving towards is really a ledger. We're back to 7,000 years ago. And the three views of the world are balance sheet, profit and loss statement, cash flow, and you can have multiple more, and those are all your projections. Those are, whatever your labeling system or whatever, and that's where we get, the parallel between CQRS and ledger systems. So, questions, concerns?
Could you briefly explain how the cash receipts are projections and what how that is a double entry accounting system?
Yeah, so I mean, it's not one-to-one, but the double entry system is every time there is a addition here, there's a subtraction here or something, right? So that's, and yeah, a ledger balances out, but the code orders don't, but every time an event is played, an event is received, we put it in some kind of root aggregate, and then it goes and creates all these projections, which could be a label or whatever. Those are snippets of data, hopefully created separately, and they're indexed and stored in the format that's usable. And not everything is in a root aggregate, which is an anti-pattern for CQRS. So that you're using event sourcing, but you're still treating it as if it's just like one blob of data. That's not a good pattern. What you want to do is you want to split it into usable forms of data, so that if the, so the cache receipt view is just the cache view, and that's separate, and you can go back to the ledger and look at it, and you can derive the cache from it, but it's its own thing. You don't have to go to the ledger if you don't want to, but you can. Does that make sense? All right. So similar to that, more than one copy of the data, like the double entry system, multiple copies of the data exist, can be tallied, verified. Incoming data is added to, never modified. So that's the events. The events are always, there's no I'm going to edit something or delete something unless it's a GDPR, the unplay sort of thing. It's a I'm going to change something, and that's a new record in the system. It's not a edit to the existing system. And like the balance sheet, there's multiple views. So you teed up this 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 slide for me. So that's on CQR SES. But meanwhile, there's a parallel world going on. What about data at rest? So the other pattern that we have is, distributed multiple replicas. Where do we see that? DNS. DNS, that's the answer. Shared, it's peer-to-peer, and each peer has a copy, so there's a lot of validation going on. Secure cryptography to create transactions. Immutable, write once per transaction in theory. What are we talking about? Blockchain. So this is a parallel, has nothing to do with CQR SES patterns, people trying to invent new ways of coding, and these guys are, starting at data-centric and reinventing something completely different. So, so these are just some of the characteristics. Blockchain is distributed, so there was some talk of somebody proposing that they should build a blockchain based on consensus. So it's kind of like high school again, right? Yeah, the cool kids get together and say, hey, this is cool, so this must be the true source, which is, I thought it was stupid, but anyway, that's my take on the things. But the reason the distributed works is because you can verify it has multiple replicas of the data, and it's not a consensus-based, it's not a voting system, it's not a, hey, 51 people like this better than that, so 51 people can get together and, hack the system, basically. But that's not the point. There's multiple copies of the, it's shared peer-to-peer, it's secure, and it's write once. So how does it work? So this actually is a distributed ledger. They even call it that, so they do relate, blockchain relates back to. And if you don't know what the body of a blockchain actually looks like, it's literally one block has data, a hash of itself, and hash of the previous block. That's what it looks like. Anyone remember linked lists? Yeah, the only difference from writing hand coding linked lists in C back in school is that there's this concept of proof of work. So basically, why is this better than a linked list? Is because the whole concept of proof of work is you actually create this proof of work that is guaranteed to take certain time to complete. And there's a lot of people who are trying to complete it at the same time, and a random person wins, and they're the ones who create the next block. And so it's very random, and that's how they maintain, the chain concept. So yeah. Anyone work with blockchain in here? You do? He could probably tell you more than me. So it's not just for crypto, What do you mind me asking? What project are you working on? What do you do with that?
Yeah, we're consultants for blockchain, so we work.
Anything that people pay you to? Yeah, that's a good place to be right now. So, yeah, so it's not just for cryptocurrency. It's not just for ICOs. There's two types of blockchain. There's permissionless, Bitcoin, Ether, versus permissioned. So Azure Hyperledger. So the permissioned, you have to sign up, you have to be approved, and then you can play chain. Permissionless, anyone can do it. You know. There's a concept of blockchain as a service. And then, you know, some of the uses are smart contracts, health records, digital voting, stock exchange, smart property, proof of ownership. There's 250 plus banks using it right now, and there are 76 jobs on Stack Overflow this morning that have a hashtag blockchain. So if you don't know it, get to know it. It's coming. So a blockchain pattern is more than one copy of data, like double entry data system. So this is very Ledger. It's built in on Ledger. Incoming data is added to, never modified, so no alterations to existing data. Multiple views of the system. In this case, the entire ledger is replicated. So it's not actually a projection versus the actual message. The entire ledger is replicated. It's kind of, you know, DNS on steroids. So, questions? I don't know why there are ants in my laptop. I do not eat in front of it, ever. It's a lie.
What are you guys working on at Microsoft? You said you were going to talk about.
Yeah, so I'm actually involved in a couple of projects that are just open source. They're pet projects with other Microsoft employees. And one is actually creating a, if people don't know this, Wix uses CQRS, but of course they don't give you your events if you ask for them. But, you know. But that's what we're working on is it's just a pet project that we want to create like a WordPress-like engine, but it's all CQRS based so that you can do, you can replay or unplay everything. So if you don't like the platform, you still have your messages and you can redo it. Think about the implication. It's all open source, so you know, happy to collaborate with any one of you. Think about it. You know, you can take this and scale it to whatever else you want to do, as far as code is concerned. And of course, we use serverless and Cosmos DB for a backend. So you know, it's not. I'm not using any pattern libraries or anything. It's just code. And then for blockchain, so you know, blockchain is great. It's amazing, but it's slow, as you can attest, probably. No? Doesn't agree? So the idea is that you probably don't want to put all your data in blockchain because it's really hard to look up, query. You know, you don't want everything hashed and, you know. So what we're trying to do is trying to figure out, and we're using the Azure blockchain stack, of course. But we're trying to see, you know, where we can actually do weighted transactions that matter, and the ones that are okay to be unencrypted, and use blockchain for the weighted transaction and the regular stuff. So, two separate projects, but they build on each other. So.
When you unplay it, does it also remove itself from the logs, or is it just the unplays?
So that's a good question, and it depends on you, right? So You can unplay to a point. You can do a soft delete where it actually will be in the eventing source and none of the projections. And in some cases, that's fine. That's all you want to do. In some cases, like GDPR, which is required by law to do something like that, in that case, you have to remove it from your, it's almost like the event never happened. And so what we do, rather than saying the event never happened, is what we'll do is we'll mark that event as something that happened that doesn't have any of the payload in it. So it'll still have, you know, where it came from, what happened, but it doesn't have any of the payload data. So anything that's sensitive to the person, you know, is
All the tip is just separate. You'll still keep a lot of the details, but
right, right. And then, you know, but you have to build the intelligence in your system to say, hey, if you get a message, if you replay it from start again, and you encounter a message that's been, you know, blitzed, then you have to build in that in your system that, hey, this, do nothing with this event. So, go ahead.
It seems like sometimes you need a little bit more than an empty payload. So for instance, if you were doing like an auctioning application,
Yep.
and you remove someone's data, but they've won an auction in the past.
Right.
You had empty thing.
Yeah, so GDPR doesn't cover that, right? So GDPR is very specific. It's not going to say things like, oh, you know, I bought from you, but I don't want you to have any record of that. That's kind of crap, excuse my language. You know, the government won't agree with that because I have to pay taxes on that money that I collected from you. So that's, you know, it's not a, that's an extreme example. But say somebody like, and I don't know if you guys know this, and this is, you know, Microsoft is global, so when GDPR came in, we had this huge, like, what you can do. So for somebody like me who has nothing to do with employee data, or I don't deal with that, but if I interviewed someone, and if I made notes about them, and if I kept them, that's governed by GDPR. I cannot keep it beyond, you know, if they call me and say, hey, destroy my data in 30 days, if I put it in any store that so conveniently makes backups on OneDrive for me all the time, and God only knows where it goes, and I can never predict whether I can delete it or not. So in that case, you know, what I do is I try not to put it on the cloud, and if it is local, then I'll delete it, and I know that it's, you know, it's not replicated somewhere. But yeah, something like that is a concern.
A slightly different example that doesn't sound.
Yeah,
so
sure.
Let's say it's like Xbox, and you've been ranked as like you won like
Right.
some ranking thing. You probably still want like a blank slot for that person in history.
Yeah, so the option there is you can anonymize a person, but you know, we all know that, you know, if I have your metadata, I know who you are. So I mean, that's more of a, I'm playing games with compliance, you know, but, you know. And that's a valid use for a system because, you know, we all live in a compliance world. So if, you know, compliance comes to you and says, hey, I want the ability to anonymize a person even though their record is in the system, fine, we'll do it. It can be done using this pattern. However, it's, you know, eventually somebody in the government will catch up saying, oh, that's not good enough. But till then, it works. So yeah. Anything else? Thank you.